Okay, physical science time. Please write down what your objective is. We'll all write it down together. But the objective reads, differentiate among types and patterns of matter. So we've been talking primarily this year about, I would say generally, about forces and energy. And now we are still talking about forces and energy. Those are concepts that span all of science. But, in fact, energy is one of the cross-cutting concepts we say. If you remember on that little poster over there, which one is it? Energy and matter is the fifth cross-cutting concept on that list. But we have been talking primarily about energy and forces as such, and now we're going to talk more about matter. And the study of matter is called, does anyone know? We talked about this before Christmas break, but obviously you have unlearned not just everything you learned this year, but everything you've ever learned in your entire life over Christmas break. And so does anyone have a guess, basically, as what it would be, as to what the study of matter is called? Study of matter and its changes. Energy and matter is the cross-cutting concept. I will give you a hint. You're going to go, oh, when you find out, because it's a very common word that happens in this room and a lot of other places. Differentiate among, was it types? Among types and patterns. Types and patterns. In matter or of matter? What if we had different kinds of matter and we were analyzing how those things react, even, we might say, as you did in your lab, which let me turn your lab back to you. Yeah, I could have. But, come on, you can do it. What would you call the study of how matter reacts? That happens a lot in this room. It happens in your body. Your body is full of these reactions. Yes, chemistry is the right answer. The study of matter. Let's just label this, even though this class is called physical science. This is the class in which we meet those part of the state standards called chemistry. Those part of the way that teaching should be in science. We have to talk about chemistry. It is our duty and privilege to talk about chemistry. And that's what we're starting to do today. So chemistry, as I've just said somewhat lengthily and with some interludes, is the study of what? Yeah, matter, which some of them are chemicals. Study of matter and its changes. So matter and the way that matter changes. Does matter change? Yeah, it does. Give me an example of how does matter change? Sun. Okay. I kind of like that, but I wouldn't say that's outside the realm of chemistry. The response was the sun, which undergoes, as you might remember, nuclear fusion. Not really. I mean, there would be chemical changes, but that's kind of one of the very few changes that you could have issued in your life that are not really a chemical change. Give me an example of a chemical reaction. You have some in front of you, but they're kind of, if you don't mind my saying so, weak. Yeah, so the Coca-Cola and Mentos things, was it a chemical reaction or was it just reacting physically? Well, that's one of the things we're going to talk about. Maybe there's some happening inside of your body. Yeah, yes. So the food changing into the energy that you use, and really you are made of food, not just that a dog or a lion or a cannibal could eat you, but also that the food that you eat becomes you in a real sense, right? The carbon, hydrogen, oxygen, and a little bit of nitrogen that make up the food that you eat becomes your body. You're built out of food. You come out of the earth. Just like an apple does come out of a tree. But what other kinds of changes are there in matter? Oh, I'll put that one. Food becoming boy. That's a chemical change. That's actually gajillions of chemical changes, like lots and lots and lots of different chemical changes. What about, can you think of like the classic chemical reaction that even third graders can do? Yeah, of what? What do you put in the volcano to make it go? Okay, baking soda. And vinegar. Yields, we might as well learn this now. When there's an arrow in a chemical reaction, we call that yields. Yeah, there's more than just that. That's very simplified. But those kind of changes are chemical reactions. Now, even though we're talking about chemistry, some of the changes that we talk about in chemistry are actually physical changes. So chemistry, we could say the changes in matter are divided into chemical properties and change, and physical properties and change. Chemical properties and change, and physical properties and change. So chemical properties are those properties of matter that describe reactions. Describe how something will react with other things. So for instance, whether or not it will burn, whether or not it will react with water, right? The fact that Joe probably has a truck with some rust on. Do you own a truck, Joe? Yeah. Does it have some rust on it? Oh yeah. I didn't even know that specifically about you, but just looking at you, I can tell you're a guy with a truck, and that truck almost certainly has rust. And that rust is when metal, which is matter, right? Metal, which is matter, reacts with water and air, and that makes rust, and that's a different thing. So that's a type of chemical property, and the rusting itself is a chemical change. Some other ones, like the physical properties, describe, we'll say, yeah, but it's not just that. Describe, I'm going to put static, meaning they roughly stay the same, attributes. Things about the matter that roughly stay the same. For example, what color is your truck, Joe? Gray. Is that how you spell gray, or is it with an A? It's different in America and England. I don't know. We'll just put both. Gray paint. The color of that paint is a physical property of it. I would say that probably the Coke and Mentos that you did was probably more realistically a physical change. So you had, this is what a Coke bottle looks like to me. What's in Coca-Cola? That's part of chemistry, first of all. Describing the attributes and the types of matter within this is part of chemistry. But what's in Coca-Cola? You can tell from the ingredients list. What is it mostly by volume or mass? No, not mostly. What is it mostly, the Coca-Cola? There is that, and we'll get to that in a second. But what is it mostly? No, not mostly. There's a lot of that. Water. It's mostly water. So it's water. It's sugar. I'll just write its chemical formula. It's phosphoric acid and carbon dioxide, which is a gas, is dissolved in it, right? So the carbon dioxide is actually part of the Coke, and when you drop your little Minto in there, bloop, the Minto, microscopically, it looks like a smooth circle on the outside, but microscopically it has all these, much like your teenage face, has all these pores on it. Mentos are actually covered in tiny little pores. And when it goes down there, each of those little pores can attract a bubble and release the bubble of carbon dioxide. And that happens a lot and fast. And so, got a mess all over my countertop. That's a physical reaction. Nothing changed about it. It's still water and sugar, phosphoric acid, and carbon dioxide. It's just the carbon dioxide has left, but it's still carbon dioxide. That's an example of a physical change. What was the other one? You guys did a bouncy ball one? Yeah. So in yours, was your bouncy ball red? The answer is yes. In yours, we put into it, what? What kind of ingredients did you use?
We used cornstarch.
Okay, so I'm just going to write these because I don't know the chemical formula. The chemical formula for starch would be the same as cellulose, which would roughly be sugar, but glue, I certainly don't know the chemical formula for glue.
And then borax.
Borax, which I think...
Cleaning stuff.
Yeah, I think that's sodium perborate, but I'm not going to write it down just in case it isn't. So we took these three things, and they came together to make a new thing, ball. But it's not just starch and glue and borax mixed. That's a key important part of chemical reactions, is that it's not just the things that it was mixed together. We'll talk about mixtures in a second, but it's not just those things mixed together, they've actually changed. It became a different thing. It's a totally different thing. It has a different set of properties, right? Give me some properties. What is starch like?
Dry.
Dry. What else would you describe starch? Dry. What else? Powder, probably. What's the glue?
Sticky.
Oogie. Yeah, oogie. We'll put that. Sticky. White. What though? Liquid. And what about the borax?
White powder.
White powder. And they came together and they made a ball, which is not dry or powder or oogie. It probably was a little sticky. It wasn't white. It wasn't a liquid. It isn't white, and it isn't a powder, right? It has different properties. It's a different thing. A chemical change occurred. Whereas in this one, even though it seems different that this is foam, the foam is still just water, sugar, phosphoric acid, and carbon dioxide. They're just in a different arrangement. So that's a totally different thing, and that's the definition of a chemical reaction. When things combine and make a totally different thing, that's a chemical reaction. By the way, I've used this abbreviation here, RXN, which is a standard abbreviation for reaction. You should probably write that down. You should probably write all this down. Anything I'm writing down, you should probably write down too. So let's get into an actual chemical reaction. The standard format for a chemical reaction, I think this is. Yeah, the standard format for a chemical reaction is like we had with baking soda and vinegar. We have the reactants here. We'll talk more about this in future chapters. And then this is the product. And in my little example here of the explosion, not really a product, but there would be some chemical products as well. So the reactants are the things that react. They yield, which means produce. Has anyone ever made like brownies or cookies or something? On the recipe, it'll say yields a dozen or yields 36 cookies. But yield means produces.
Chemical
Yes.
reaction with that. I was making cookies, and I added some baking soda, and the sugar exploded on me.
The sugar did?
Yes.
The sugar and baking soda
It's
reacted?
like a melted sugar.
Oh, I
It was
see.
too
So you
hot.
had melted sugar. That's probably actually a physical change. Because another example of physical change is state changes. Let's put that over here. Actually, I'm glad you brought that up. We'll talk more about this in the next chapter, but state changes are physical changes. So when sugar melts, it might seem like a totally different thing. It's a liquid afterward, right? It was a solid, now it's a liquid. But it's still just sugar. It's still sugar, it's just now melted sugar. In the case of sugar, it also actually decomposes. That's why it turns brown. So that's not a terrific example. There are chemical reactions within the sugar melting. But melting in general is a physical reaction. So what kind of things, this will be probably, let me make sure this is true, but this will probably be the last thing that we talk about today. What kind of things make up matter? So chemistry is a study of matter. What kind of things make up matter? First of all, besides matter, what else is in the universe? There are only really two kinds of things in the universe. Matter and, you could say stuff like thoughts and dreams and prayers and ghosts, but of the things that are observable, I won't say real, because there probably are, and certainly in my opinion are, things that are real beyond what can be observed. But of the observable things in the universe, there are really only two: matter and energy. Matter and energy. So we're talking right now about matter, though. So within matter, there are only really two kinds. There are pure substances, and all of this, of course, is broken up in the way that make it easier for human beings to think about. You could say there are two kinds of matter: apples and not apples. But we're going to break it up in this way because it'll make it more convenient for you. So pure substances and mixtures. There are overlaps between these, and there are things that don't really neatly fall into either category. But generally, at the freshman level, we talk about pure substances and mixtures. Within pure substances, we have elements, chemical elements, and compounds. Can you give me an example of an element and tell me where you found it?
Iron.
Iron.
Hydrogen.
Where did you find the element? Yep, every element, that is every kind of atom, every different arrangement of protons, every kind of atom is found on the periodic table. Iron, hydrogen, my favorite one is gold, but all the elements are found on the periodic table. What about a compound? A compound is a fixed ratio of combined elements. So for instance, give me a really easy one. What did you say? Yeah, H2O. It has to be H2O because that's what makes it water. Hydrogen is a gas. Oxygen is a gas. How do two gases come together to produce liquid water? Well, it's a totally different thing. Compounds are, let me give you another example. H2O2. The only thing that's different about that, still hydrogen and oxygen, the only thing that's different about it is the ratio. Do you know what H2O2 is? It's hydrogen peroxide, which if you drink it, you will, I mean, you may not die, but you would wish you didn't. It won't quench your thirst like water will. So H2O2, the only thing that's different about that is the ratio. So the ratio really matters. So pure substances can be either elements found on the periodic table or compounds, which are set ratios of elements that are bonded together. We'll talk more about those and bonding and chemical reactions in a future chapter, but for now, this is how they're broken up. And then within mixtures, do you remember from your vocab, what kind of mixtures do you have? Coke is a mixture, for one thing. Coca-Cola, I mean, not cocaine, but Coca-Cola is a mixture. The glue would be a mixture. The Mentos are probably a mixture. There are two kinds of mixtures. Do you remember from your vocab? Heterogeneous or heterogeneous. And just say it. It's okay. We're all going to talk about it in a second. Homogeneous. So the reason we use these prefixes hetero and homo, hetero means different. Like someone who is heterosexual, the opposite sex, the different sex appeals to them. Someone who is homosexual, the same sex appeals to them. So that's how we remember. Hetero is different, homo is same. Heterogeneous are those mixtures that are different throughout. They have a different composition. So they have a different composition. I abbreviated both those words, different composition throughout. So like pizza. Pizza is a classic example of a heterogeneous mixture. If you don't like the pepperonis, you can take the pepperonis off. They're different. The pepperonis are different from the rest of it. In a homogeneous mixture, it has the same composition throughout. So for instance, let's put salt, or let's put salt water. You can't with your little paws go through and pick out, oh, I don't like the salt, I just want the water, right? That would be very convenient if you could, because then you wouldn't thirst to death at sea. But you can't just go through and pick out, it all looks the same. It's all one similar thing. That's a homogeneous mixture. Homogeneous mixtures are also sometimes called solutions. And of heterogeneous mixtures, we have several types, including, from your vocab, which you should know, suspensions, colloids. There was another one. Suspensions, colloids. What was the other one? Oh, that was it. Do you have questions about the kinds of matter, the way we break up matter in chemistry? Pure substances and mixtures. Do you have questions about that? Or what those things are further broken up into? What about the physical properties and changes or chemical properties and changes? Questions about that? Okay.